Good morning, students. Your physics teacher, myself Alok Kumar Mishra, is going to discuss about the Fleming's right hand rule, which is very important in field of physics. So, what do we mean by Fleming's right hand rule? Before this, the rule is Fleming's left hand rule, which was discussed in previous class. Here today we will explain about the Fleming's right hand rule, what is its significance, importance in the field of science. So it is used to find the direction of induced current which is produced in a conductor moving in magnetic field. Okay, so this rule is very similar to the Fleming's left hand rule, but the minute difference is that this rule is used to find the direction of induced current, and in Fleming's left hand rule, that rule is used to find the direction of force exerted on the conductor placed in magnetic field. So this rule is very important, which is used to find the direction of current. I have drawn one clear image diagram in which wire is kept in between magnetic field. Wire is kept in and it is allowed to move. When the wire is allowed to move, then induced current is produced because it is placed in magnetic field. So the statement is that this rule is also known as dynamo rule, generator rule, because of generator produces electric current by the use of the magnetic field and the coil in these systems. So as dynamo is the device which is used to produce the current, induced current, when mechanical effect is produced. Okay, so mechanical energy is converted into electrical energy. So that system works on this principle. Okay, and electromagnetic inductions also. So the rule is that when we stretch forefinger, thumb and middle finger of right hand, thumb, forefinger, you can say first finger, index finger and middle finger, mutually perpendicular to each other, mutually perpendicular to each other, such that the forefinger indicates the magnetic field, middle finger will indicate the flow of current, if the thumb will indicate the motion of the wire, okay, placed in magnetic field. So once again we will review this statement: stretch thumb, forefinger, middle finger mutually perpendicular to each other in such a way that the thumb represents the motion in the conductor, forefinger represents the magnetic field, then certainly the middle finger will represents the amount of flow of current, induced current, direction of induced current. So this is the law. So how can we remember easily? This is very difficult to remember. So here thumb, what is thumb? M is given, so motion is given. Motion indicates the force also. So force is applied on the conductor, and the forefinger magnetic field Forefinger indicates magnetic field. Force F is here given. So force is field is given. So magnetic field. Central finger, middle finger is also known as central finger. So that indicates the induced current produced in the conductor. So here there is a one activity. If there is a magnetic field north to south, field is from north to south. Now the magnetic field is here from north to south, and a wire is placed here in such way that the motion of the wire takes place downwards. Then the current will produce, induced current will be produced. That will indicated by the central finger. So this is the central finger, middle finger. So this is the law of Fleming's right hand rule, which plays very important role to find the direction of induced current produced in the wire, which is placed in magnetic field perpendicularly. So this is very important. Okay, thank you, thanks a lot.